Welcome to episode 2 of Enzyme Exam Questions and Answers based on questions about enzymes, which are possible questions you are going to find during your exams. Of course, we are going to provide some of these questions to you and also provide answers and explanation at some level to help you better understand this topic for a better pass grade. Whether you're in the high school, the university, or in the secondary school, this is for you. So in the last couple of days, we post the first episode, some questions and answers as well as explanation. So we are going to be continuing with this episode, that is episode 2. And if you have not yet watched episode 1, I'll put the link below this video so that after watching this particular episode, you can go directly there and also watch that particular episode 1 to catch up with this level. So the first question in this episode 2 is, what do you understand by the meaning the lock and key hypothesis when it concerns enzymes, or the lock and key model? Of course, the simplest explanation is the fact that the lock and key hypothesis or model suggests that the substrate must bind to a specific active site of an enzyme which is specifically fit or shaped to fit that particular substrate. So we are looking at two key terms here: specifically shaped and to fit a specific substrate. That is specificity. The term specific is very relevant for this lock and key hypothesis, which suggests that a specific substrate must bind to the active site which is particularly shaped for it to fit that particular substrate. Just the same as a key will fit to a specific lock. And this is where the term comes from, the lock and key hypothesis. The next question is, what is the optimal temperature for most human enzymes? So this question is specifying the term human enzymes. Human. First, to get it correctly, you need to first of all understand that the temperature of our body should fall at 37 degrees centigrade as the normal temperature of our body. And if at all they are talking about the optimal temperature of human enzyme, then of course they are talking about 37 degrees centigrade as well, because that's the temperature of human body. So the answer is at 37 degrees centigrade that human enzyme will function at its optimal level, that is at its best. It is at 37 degrees centigrade. The next question is, what is the effect of competitive inhibitor on enzyme activity? The term here is competitive inhibitor. You first of all need to understand what is the term competitive inhibitor. First, you need to understand that competitive inhibitor resembles the substrate, and it goes to bind to the active site of an enzyme and preventing the real or original substrate from binding to the active site. That is why it is termed competitive inhibitor. They resemble the substrate and goes to bind to the active site, stopping the real substrate from binding to the active site. And for us to overcome this, of course, we need to increase the substrate concentration. And when the substrate concentration has been increased, this competitive inhibition will be either reduced or stopped. But if you have been given this as a multiple choice question for you to select the correct one, you might have series of options like option A, competitive inhibitor completely deactivate enzymes. B, it blocks the active site of the enzyme temporarily. C, it enhances enzyme activity. D, it increases substrate concentration. The correct answer here is B. It only temporarily blocks the active site of an enzyme. But when the substrate concentration is being increased, of course, this will be reduced or stopped. And therefore, the substrate will now tend to start binding to the active site. The next question is, what is a cofactor? What do you understand by the meaning cofactor? If you look at enzyme, of course, enzymes are biological catalysts which are protein. They are specific protein which are or act as catalyst. Now, when we talked about cofactor, we are talking about non-protein molecules, because enzymes are protein in nature, they are protein, but cofactor are non-protein, and they also bind to the enzyme for it to aid in enzyme activity. That is, it helps in enzyme activity, and its major role or function is to stabilize the enzyme substrate complex or assist in the enzyme catalytic process. You see, the difference here between cofactor and enzyme is the fact that cofactor are known, that is known protein molecules. But enzyme, on the other hand, are protein molecules. This is the difference. But of course, these cofactors are relevant in the catalytic process because they help to stabilize or assist in the catalytic process and also stabilizes the enzyme substrate complex. The next question is, what is allosteric regulation? So when you hear the term allosteric, it is when the molecule tend to bind to another site other than the active site of the enzyme. That is, it does not bind to the active site, but rather it binds to another site which is different from the active site, also known as the allosteric site of the enzyme. And these can either activate or inhibit the enzyme activity by changing its shape or function. In other words, if a molecule instead turns to bind to the allosteric site, which is not the active site, it might either speed up the rate of reaction or reduce the rate of reaction by changing the shape and function of an enzyme. So allosteric site and the active site of an enzyme are different. The active site is the site where the substrate will bind, but the allosteric site is another area or region where molecules tend to bind rather than in the active site. And when this happens, it tends to alter the shape of the enzyme. And when this occurs, it will either activate or it will inhibit enzyme activity. We are going to end here for today, and we are going to continue with the upcoming episode. You want to make sure to subscribe and enable the notification bell icon so that, of course, you are going to receive new post notifications. And when we publish a new video on this particular episode, you are going to be notified for you to watch. And if you also want to see additional questions and answers, then you want to make sure to check relevant links below this video description. See you again in the next upload, and bye-bye for now.